Hi everybody, today we are going to take a look at a review on solving right triangles using sine, cosine, and tangent. So this is something you did back in geometry. I'm going to give you a quick review here. It also relates really closely to what we did when we wrote all of our ratios in the coordinate plane. So here at the top, I have a review of your ratios. We have sine, which we've been using as y over r, is opposite over hypotenuse. So we're looking here, opposite over hypotenuse. Cosine is adjacent over hypotenuse. So this would be the adjacent one. And tangent is the opposite leg over the adjacent leg. Our reciprocals also still work here, so cosecant would be hypotenuse over the opposite. Secant would be hypotenuse over the adjacent, and cotangent is adjacent over opposite. So rules for finding and stating solutions. All angles will be labeled with capital letters, and all sides will be labeled using a lowercase letter. So for us here, if I'm looking at this triangle up above, and this angle is A, B, and C, my angles would be angle A, angle B, angle C. The side opposite each angle is labeled with a lowercase version of that. So here is angle A. The side opposite of angle A, I label with a lowercase a. The side opposite angle B is labeled with a lowercase b. And the side opposite angle C is labeled with a lowercase c. We need to use original, so that just means given information to solve for missing angles and sides. That means I won't be finding a missing value first and then using that value that I found to find other missing information. The only time I would do that, I'll point out in our examples. And then all angles are going to round to the nearest tenth and the sides to 3 significant digits. So in part A here, we're going to find the measure of the side that's labeled. So here I want to find side x. So x here, I'm given this angle A is 61. X here is the leg opposite that. And I also have the hypotenuse. So that tells me I want to use sine. So the sine of 61 equals opposite over hypotenuse. Now before you go ahead and plug anything into your calculator, we need a calculator ready answer for H. So here, calculator ready means I'm going to isolate x all the way before I touch my calculator. So I'm going to multiply both sides by 16, so 16 cancels out on the right, and we get x is 16 times the sine of 61 degrees. This is calculator ready. Then I'll go ahead, I'll plug that into my calculator, and I'll round to 3 significant digits. So we get 14.0. So both of these are a part of my final answer, so I'll circle both. In number 2 here, I'm given angle B. We're looking for x, which is the hypotenuse, and we're given this adjacent leg. So we have adjacent and hypotenuse. So that tells me I might want to use cosine on this. So cosine of my angle equals adjacent over hypotenuse. So when you solve for x, so you multiply both sides by x so it cancels out over here, and then I'm going to have to divide both sides by cosine of 33 to isolate x. So we get x is 2 over the cosine of 33. So that is my calculator ready answer. And I plug that right into my calculator and round to 3 significant digits, and we get 2.38. If you're plugging these values into your calculator and you're not getting the answers that I have, I do want you to check to make sure that your calculator is in degrees mode, because we're plugging in degrees. The calculators have a degree mode and a radian mode, so make sure that you're in degree mode when you're plugging in degrees. Last one here, for this angle, we're looking for the opposite leg and we're given the adjacent leg. So opposite and adjacent, which means I might be looking for, I might be using the tangent ratio. So tangent of 54 equals opposite over adjacent. So I'll have to multiply both sides by 13. So we get x equals 13 tangent 54. So that's my calculator ready answer. And then I'll go ahead and put that into my calculator and round 3 significant digits. If I had units on my lengths here, I would include the unit on my answer. On 4 and 5 here, we are given side lengths, but we need to find angle measures. So on this one, I'm given the leg adjacent to the angle that I want to find and the hypotenuse. So adjacent and hypotenuse, which means I might want to use cosine. So cosine of theta, we don't know what theta is adjacent over hypotenuse. Now, in order to solve for theta, I have to somehow undo this cosine. So to undo cosine, we need to take the inverse cosine of both sides. So that gives me the theta on one side, because the inverse cosine and the cosine cancel each other out. So we have theta equals the inverse cosine of 5/8. And you should have an inverse cosine button on your calculator. You might need to use the second button. It might be second cosine in order for you to get there. But this is my calculator ready answer. And when I put that into my calculator and we round to the 10th for our angles, we get 51.3 degrees. On 5 here, I have this angle. I'm given the opposite leg and the adjacent leg. So that tells me I should be using tangent. So tangent of theta equals opposite over adjacent. And you might notice that I can reduce a 2 out of these, so you can reduce out 2. So to get theta by itself, we're taking the inverse tangent of both sides, so that the inverse tangent and the tangent cancel each other out, and we're just left with theta. So theta equals the inverse tangent of 3/8. That's calculator ready. And I'll plug this right into my calculator, and we get 20.6. Last problem here. We are solving the triangle. Solving the triangle means to find all sides and angles. For us, I'll just ask you to find the missing sides and missing angles. So I have this angle here, this opposite side, and I'll be able to find, I know this angle is 90, I'll be able to find angle B by subtracting 90 and 21 from 180. So that's going to be the first thing that I find. So angle B is 180 minus 90 minus 21. So that's 69. So this is really the only case where I'll say it's okay for you to use non-original information. You weren't given this. However, your answer for B is exactly 69 degrees. We didn't need to plug it into our calculator and round anything like we did in part B up here. So as long as you didn't have to plug anything into your calculator and round it, you can use this if you'd like when you're solving for your missing sides. So that's 69 degrees. Okay, so my missing sides, I need to find side B and side C. So first what I'm going to do, I'm going to find side B here. I'm going to find that by using my tangent ratio with the 10.4 and my angle 21. So the tangent of 21 equals 10.4 over B. So if I isolate B, it's 10.4 over the tangent of 21 degrees. So there's my calculator ready answer. And when I plug that into my calculator, it's a side length, so I'm rounding it to 3 significant digits, 27.1. My other missing side is side C. Now, one thing to point out, I cannot use this side B that I just found to find side C. This is not original information. It was found and then I had to round it. So any rounded information I don't want to use to find a missing side or angle. So I'll find side C using my angle 21 here, and I'll use my sine ratio because we have the opposite leg, and I'm looking for the hypotenuse. So the sine of 21 equals opposite over hypotenuse. So calculator ready is 10.4 over the sine of 21. And we plug that right into our calculator and round to 3 significant digits. That's 29.0.